Good morning. So let us discuss KNN algorithm. KNN stands for K nearest neighbors. Today let us see how it works. KNN algorithm is a supervised machine learning algorithm that works on structured data. It can be used both as a classification as well as regression algorithm. The basic idea of K nearest neighbors KNN algorithm is proximity or distance based fitting or prediction or decision. It can be used for both classification as well as regression, and it is a non-parametric algorithm. So there are no parametrics or a no fitting equation that the algorithm is going to derive. Rather, it based on the nearest neighbors of that new data point, it calculates its value, target value, or predicts the class of the new data point. This algorithm is called a lazy learner because KNN algorithm doesn't develop any equation or doesn't calculate any parameters during its training phase. Since it is non-parametric, only when the testing data comes, it starts working. For each test data point, it starts calculating the nearest neighbors and predicting the target class or target value of the new point. So, because of the limited training period or technically zero training period, KNN algorithm is called a lazy learner. All our machine learning algorithms starts generating parameters and fitting the data the moment they receive training data. So other algorithms mostly are called eager learners, while KNN algorithm is called a lazy learner. Now let us look at how KNN algorithm works. So KNN algorithm, the basic outline of how the algorithm works for both classification and regression is the same. Once a new data point has come in, as you see in the picture, so the nearest neighbors are picked for this new data point based on proximity. So it calculates the distance of each new point to all the training points and picks k nearest neighbors. The value of k is decided after calculating the total error, classification error or regression error of the test data set for different k values. So, for example, if I take three numbers, how much error am I going to get? If I take four neighbors, how much error I'm going to get? In this way, the value is calculated, the error value, and then we decide the best k value. Now, if it is a regression task, from the neighbor's value of target, so the average target values is taken to be the target value of the new data point or test data point. If it is a classification task, the common class or the majority class from the neighbors is associated as the target class for the new data point. How do we choose the right k value? As you see in the picture, let us assume that we are talking about a binary classification wherein we have class A and class B. As you see that as a new example comes to classify, if I take three neighbors, you see that the immediate three neighbors, based on the immediate three neighbors, the new point could be classified as class B. Now, similarly, if I take five neighbors or seven neighbors, you see that there are high chances that the point can be classified as class A. So different choosing different k might give us a different classification each time. So what do we do is, since based on the k value, the prediction of target value for the test point changes. So we will try to plot different values of k versus the error that is created for each k value. Now, using this plot, we try to decide the best k value. Usually, it is recommended that we take at least a value of 4 for regression and a value of 5 for classification. And for classification tasks, it is advised to keep the k value odd to avoid any tie. Larger K may turn out to be computationally intensive because for each testing point, all the distances need to be calculated, the neighbors need to be picked, and then the calculation of averaging needs to be performed. So, larger K might turn out to be computationally intensive. Now, since the training time for KNN algorithm is very less, it is called lazy learner, but at the same time it uses huge amounts of memory because for each of the training testing point coming in, it will have to use all the training data and calculate the distances and decide the neighbors. This algorithm is computationally intensive, particularly in the testing phase. So this is the end of how KNN algorithm works. Let us meet in the next video.